name is Hugh O'Keefe. I'm VP of Engineering with Ashling, and I'm here in the RISC-V Summit in Santa Clara 2018. And today Ashling is launching their RISC-Free IDE for C and C++ development on RISC-V architectures. What I'm showing today is the RISC-Free software environment running on a PC, the Ashling Opella-XD JTAG probe, which provides the debug link between the PC and the target system, the RISC-V powered target system. This target system is called a Vega board, created by the OpenISA organization, and consists of a RISC-V microcontroller with 2 RISC cores in it. Using this setup, you can create your software, write your software, compile your software, build and debug. I'm going to very quickly show you how to compile your software. Here we have the RISC-Free environment. It's an IDE based on Eclipse. So to build your project, you can simply build it from within the environment. Once your project is built, you can invoke the debugger from within the environment and debug the project on the actual Vega board. So I've built my program. Here you can see the compiler has been executed and the build is finished. To debug, I launched debug configuration. In this case I am debugging using an Opella-XD, so I select the Opella-XD option. Everything else should be pretty much set up to go. So to start, I just click on debug. RISC-Free then changes the perspective from the C++ perspective into the debug perspective. And here I am within the debugger, and you can see I have run up to main, so my program is ready to start debugging. In these other windows you can see things like your variables, your registers and your peripherals. We also have a terminal window that will show you any serial activity by your application. Here we have the main debug window. So for example, if you want to step over a particular line of code, you can use the step over button. And as you can see, as the program executes, the source window display updates to show the current line. If you want to set a breakpoint, you simply double click on the ruler to set a breakpoint, and the program can now be executed and will halt when it actually comes to that particular point. You can see in the last few lines my program did some output to the UART by printfing to the UART, and those lines are shown here in the comms, the serial terminal window. If I run the program, you will now see my program is running, and if you look here at the target with the camera, you can see that the LED colors are being cycled by the running program. When I hit halt, you will see that the LED pauses and is turned off. So ladies and gentlemen, that concludes the RISC-Free introduction. Thank you for watching.